So example 8, we've kind of done already when we did the second part of example 7. And so what we want to do is compare some properties, or a specific property in Euclidean geometry that seems fairly obvious, and see that when you assume the world is different, or the world you're living in is different, it has different implications for you and how you interpret things. So example 8 says, for the property below from Euclidean geometry, write a corresponding statement for elliptic geometry. So elliptical is like spherical. Think of the Earth, living on the Earth. For 3 collinear points, exactly one of them is between the other 2. So that's the Euclidean one, is like this. Here's my collinear points. You always have one between the other 2. This point is in between here. This point is in between. Okay? But now we have, as I showed last time, we have our sphere, and I'll just draw the equator in so we get the feel for it. And then I'm going to have some other great circle with points on it. I'm obviously drawing it quickly here. And we said if we have these 3 points on here, it just takes turns which one is in between. If you start here, and whoops, if you start here and go around, then the top one is in between. If you start here, then the bottom one is in between. Okay? If we do it the other way, if we start here at the bottom point and go around, then the top point becomes in the middle. But if we start at the bottom point and go up, then we're going to get the middle, what looks like the middle on this side is actually in the middle. So really they all take turns being in between. So let's write the implication here. The implication is for 3 points on, well, what's the equivalent to a line? Well, it's a great circle. For 3 points on the same great circle, all the points are between the other 2 points. Sorry for my handwriting, because it's not my handwriting. Maybe I should erase this one here. So they're all between each other. You're going to have to do something. You'll have a number of series of statements in the challenge problems that will ask you to consider what's the implication, and you'll try to come up with some kind of rule or some kind of explanation about what happens in that kind of world rather than just a flat Euclidean world. Thank you.